Question 7 on the Christmas test. Mary is 25 years old and intends to retire at the age of 65. That's 40 years' time. She begins to calculate how much she needs in her pension fund. All calculations, 4% annual growth rate. Mary wants to receive a payment of 30,000 at the start of each year for 25 years after her retirement. And starts off with this: write down the present value of a future payment of 30,000 in 1 year's time, correct to the nearest cent. So the present value of a future payment of 30,000 will be less than 30,000. If we said to the bank, I want 30,000 in a year's time, they'll say, well, give me a little bit less. How much less? 1 plus the interest rate less, 1.04. That is giving me 28846 spot 15 to the nearest cent, 153, so 15 to the nearest cent. And then part 2, one of these questions, write down the present value of future payment of 30,000 in T years time. That will be 30,000. If you do it this way, 1 plus the interest rate, 1 plus the interest rate, 1 plus I, the last part goes to the power of 1. So if we want 4% and T years, it's 30,000 by 1 plus the interest rate to the power of T. So how much, correct to the nearest euro, will Mary require to have in her fund to guarantee this payment? Right, so she retires on this day and she wants 30,000 immediately. And the following year she wants another 30,000. So we know that the future value of that, the present value is 1.04. The following year there will be another 30,000, 1.04 squared, all the way to that last year. Now there's 25 terms in the sequence here. There'll be 30,000 divided by 1.04 to the power of 24 here. So we have Sn, we have the sum of n terms. Sn is equal to A times 1 minus or to the power of n over 1 minus or. So A is 30,000, the first term. Or we'd have to multiply every term by 1 over 1.04 to get from one term to the next. So we're going to have 1 minus 1 over 1.04. Now if we imagine it's 1 over 1.04 to the power of 25, there's 25 terms. So that will be 1 to the power of 25 over 1.04 to the power of 25. So the 1 to the power of 25 will just stay as 1. 1.04 to the power of 25. And then divided by 1 minus 1 over 1.04. And typing this into your calculator a couple of times to double check. I checked a couple of times, it gives me 487, and actually the first time I didn't get this, it was only the second and third time, 409, 487, 40889, 40889, and it doesn't ask, oh it does, nearest euro, so 487, 409 euro. So now Mary's going to invest to save up this much money. She's got how many years to do it? 40. So a couple of giveaway marks here. 40 years to retirement by 12 months is 480 months. A higher level math question. But it's only 5 marks within 50. Fifth part of this question, calculate the rate of interest compounded monthly that will be equivalent to an annual rate of 4%. So the way I teach you guys, 1.04 to the power of 1 over 12 equals, that gives 1.00327 I would take as many decimals as it gives in these questions just to be more accurate. So now in the next part of this question, if Mary makes equal payments of P over the next 480 months, what value of P, correct to the nearest euro, will give Mary the retirement fund she needs? So we know that this pension fund is going to have to be equal to 487, 409. The monthly interest rate is going to be 0.00327, 37398. Time period N or T is going to be 480. The formula we're going to use is A is equal to P times I times 1 plus I to the power of T over 1 plus I to the power of T minus 1. I need to double check. I'm doubting myself. In fact, it is correct. And we're looking for the value of P correct to the nearest euro, and that's the equal repayments. And I don't know if they deliberately did that in this question, but P actually in this question is A. So you could have easily been confused here. Like, why would they call it P? Surely they should have said A, but that's the Department of Education. This was a leaving cert question, or else Mr. McGann deliberately did it himself. So we have A, this is just formula use now, calculator use, double check. It's going to be the amount borrowed, 487, 409, times I, which is the 0.003273738, times 1 plus I to the power of T. So I'm going to have a huge 1 plus I, 1.003273738 to the power of, what we have, 480 all over 1.003273738 to the power of 480 minus 1. Now type this in a couple of times and see what you get. Having checked it twice, I'm coming out with 2015, and I actually rounded it off the second time to 374. I took off these 3 for all of them, and it didn't really change the value at all. So 5 significant figures there is probably easily enough. 1, 2, 3, 6 significant figures with the 4. And hopefully that's the end of the financial maths question.